Hi everyone, welcome to FabForge 5. I'm glad you're here. We design and make fun and unusual projects, and we always learn something along the way. Today we're making a M&M launcher, a smart M&M launcher. We will automatically measure the distance to a bucket or basket, set the proper launch velocity, launch an M&M, and hopefully have it land in the basket 100% of the time, or maybe 80% of the time. We'll see what happens. We'll make it with 3D printed parts, an Arduino microcontroller, a servo, a stepper, a Ping ultrasonic sensor, and a bunch of small hardware pieces. We'll have fun doing it, and we'll definitely learn something along the way. Let's get started.
FabForge 5.
A few years ago, my kids and I built a ping pong ball launcher. Same concepts as the M&M launcher, but it used compressed air to force the ping pong ball out of a small tube. You would pump up the small compressed air tank with a tire pump, 7 complete pumps to be exact, and then it would use the ping sensor, same one we'll be using, to measure the distance to a bucket. Once it measured the distance, you'd push the launch button, and in this case it would set the angle, the launch angle in the tube, and then release the air to fire the ping pong ball, hopefully into the bucket. The ping pong ball launcher worked well, but it had some variability in the air pressure. If you didn't pump exactly 7 pumps, or if there was a small leak in the air, the distance didn't exactly work out right. I think we can do better with an M&M launcher. Our launcher will spin a wheel that will launch the M&M using its circular or rotational velocity. And we'll always have a 45-degree launch angle. That removes that variable, and now we just have to change the rotational speed of the wheel to change the launch velocity. We'll launch our M&M into a container from our launcher in a projectile motion or ballistic trajectory. If we launch high, it goes a short distance, low, short distance, but it turns out if we launch it at a 45-degree angle, that's the optimum angle for the greatest distance, d. The velocity we'll call v. The projectile motion equation looks like this, where g is the constant of gravity. If we launch at a 45-degree angle, it simplifies into this. Easy. We can use this calculation in our Arduino program to figure out the exact velocity. I use Fusion 360 for design. If you spend a bit of time designing something in 3D in something like Fusion 360, it saves you a ton of time when you're actually building something, because you're pretty sure things will fit, will be the right shapes, and will work right if you design it in 3D first. Here's how the finished M&M launcher will look. Now let's start putting it together. We'll use Slicer to prepare our 3D models for 3D printing. Here's a layout. Here are the sliced versions. The green areas are supports, which will break away after we've finished with the 3D print. We'll export the G-code, set up our 3D printer, and get those things printing. We'll print the tire for our feed wheel out of TPU filament, which is flexible filament, also called Ninja Flex. It's fantastic stuff. It's very flexible. You can do tons of things with it. You can print flexible hinges, O-rings, gaskets, tires, all kinds of things. I love working with it. You can see we have a hollow tire actually, so it should have some good flex to it. It should grab our M&Ms well as they're in the feed chute to push them out. A couple things to remember about flex or TPU if you use it. One is you have to drastically slow down your extrude speeds. Because it's so flexible, the extruder has a hard time pushing it through the nozzle if you ask it to push it too fast. It just bunches up and shoots out of the nozzle in a big scramble of spaghetti all over your build plate. So you have to slow down the extruder. Also, it's really hard to pull off of a cold build plate. You want to pull it off when your plate is still warm. Otherwise, it's really sticky. But Flex works great. We'll get this printed up, we'll finish it up, and then we'll start putting things together. One of the advantages of doing a design in 3D CAD before you actually 3D print it is you can put all your holes in the different places you need them. You can make them exactly the right size and make sure they're all lined up in the right places. It makes it really easy to put things together once you're in the assembly stage. All right, it's the next day. I've done some more work on putting together all the motors and electronics here. So one thing, we're using an Arduino microcontroller. We're also using an Adafruit Motorshield to power our stepper motor, which spins our launch wheel here. A couple things I figured out. So last night I spent a few hours working on different problems. First issue, this USB cable that runs from my laptop to the Arduino is bad. So that's one problem. That took me a while to figure out, but we replaced it with a working cable. Who knew that those tiny cables would go bad like that? Second thing, our ping sensor on the very top of our unit here. I had mounted it a little bit lower. You can see a little spacer I had to add here. So when it was lower, it was still a good bit above the launch wheel, but for some reason, the ping pulses coming out, the little ultrasonic pulses, would probably reflect maybe a little bit from the motor anyway. So it would give me a constant reading of 14 centimeters, no matter how far away a target was. That was frustrating. So I finally figured out that it was because it was just somehow too close to something below it, which you wouldn't think would be a problem, but it was. I added a spacer to make it a little bit higher, and that solved that problem. So remember, I said we would learn things along the way. That's one thing we've learned. We will now call this version a prototype version because now it has a modification in it. If I do this again, I'll simply make this tower higher in Fusion 360, and then 3D print it again and make this sit a little bit higher. So we solved the ping problem. That was good. Bigger problem is that stepper motor. So I picked a stepper motor because I thought you could very precisely spin a stepper motor a precise RPM, which we need to make sure we launch our RPMs at the right velocity. And I've even been measuring it. You can see a little white stripe on there. That white stripe helps me use my RPM meter, which I don't have with me right now, that measures the exact RPM. The actual RPM versus the requested RPM is vastly different. It turns out that stepper motors aren't exactly designed to spin in an exact RPM. They're meant to spin an exact distance and be very precise that way. And I beat my head against the wall for a couple hours figuring out different potential fixes for that. It turns out that there's so much overhead in the communication with the Arduino and the Motorshield and the way your stepper works that there's only so much you can do to make the speed precise. So, plan B. We're going to go to a regular DC motor and do some testing on that and see how precise the RPM is. And we're going to ditch our nice little stepper motor here and try a regular DC motor. We'll see. Stay tuned. Getting frustrated.
Inconceivable.
Yeah, I know. Okay, I kept working on this thing, and I think I got it to a point where we can give it a try. Here's what I did. So replace the stepper motor with a regular old 12-volt DC motor, which I salvaged from an old printer. That's connected, of course, to our feed wheel. And I had to redo the 3D printed support for that, so it has a new motor support. By the way, M&M colors, obviously. Couple of questions about what kind of plastic I use when I 3D print. This is all PLA. The blue and the green is PLA. The red is PET. You can kind of tell the PET has a bit of a sheen to it. I like PET. It prints really well and it looks fantastic. But PLA is great too. I regularly use both. I'll show you how it works. I'm going to aim it at the back wall here, which is about, 10 feet away, 300 centimeters. When I push the button on top, you'll see a green light flash on a ping. That means it's taking a distance measurement. Then you'll see the motor spin up to what it thinks is the right velocity. Then you'll see the servo spin the little feed here. I took the chute off for the time being, so you can see that. So watch all that happen. Let's give it a try. Okay, so you get the idea. So it takes a measurement, spins up the feed motor. When it hits the right RPM, the feed servo swings over to push an M&M into the chute, and then it swings back, then the motor slows down. Now, I'll put the chute on, we'll get some M&Ms, and we'll give it a try.
We're gonna need more M&Ms.
Yes, we're going to need more M&Ms if we keep doing this. We're going to make some changes to the Arduino code. There's a calibration factor in it that will change to try to zero in the motor RPMs a little bit better. Let's switch that and give it a try. All right, we're going to test this, see how it works. A couple of quick things. I added some rubber bands onto our fancy TPU tire. The tire wasn't quite wide enough in diameter, and it's a little bit slick, so rubber bands I think will help with that. And then I haven't talked much about the Arduino program for this M&M launcher. So we obviously have a Arduino Uno here with a Adafruit Motorshield sitting on top of it. And then we've got, of course, our ping sensor. So a couple of things about programming Arduino. If you haven't done it, it's not as difficult as you might think it is. It's really pretty simple. You can download the free Arduino programming environment, plugs into your laptop here through a USB connector. And then that environment comes with a ton of examples for all kinds of different applications, servos, motors, sensors, etc. And then if you're using a specific type of sensor or module or shield, you can download a library for it. And that library also comes with a lot of coding examples. So for example, the ping, you can download the ping library. You get about 3 or 4 examples of coding to do different things. And then the motor shield comes with the library. You can download examples on how to run a stepper motor, a regular motor, a servo motor, etc. And so really, you can just pull those little code examples, put them together in one big program with a couple of mouse clicks, do a little bit of tweaking, and it will work just fine. So don't be intimidated by programming Arduino. It's a great thing to start with, and it's a lot of fun. Let's give it a try here. We'll try some tests and see how it works. Fingers crossed. All right, we finished our project. We tested our M&M launcher. It works, not every time, but remember I said at the very beginning, 100% would be great, 80% reasonable. We kind of hit the 80% mark. Now we did have an issue. We obviously couldn't use the stepper motor we initially wanted to use. That would have been great because it would have had really precise, launch velocity. Something I'll probably revisit in the future. That is a goal of mine. We could add a very precise RPM measurement system to this to give some feedback to our Arduino to make sure our RPM was exactly dialed in and right for every launch, maybe a future project. But right now for this, I'm going to say after testing it, we're going to declare success.
I'll alert the media.
Yeah, thanks. And yeah, we did have a failure by not using a servo motor.
Failure is an option.
Yeah, failure is an option. And actually, one of my philosophies is if you're not failing, maybe you're not trying hard enough. Anyway, we're happy with this. We've got some loose wires here. We'll clean them up with some zip ties, and we'll just go ahead and have some fun with this and eat some M&Ms along the way. I really appreciate you joining me for this episode. Make sure to like, subscribe, ring the bell so you know about additional episodes as I upload them to YouTube. And yeah, I enjoyed the ride with you. Make sure to take good care of each other, and I'll see you next time. Bye.